Hi friends, welcome to Linux Essentials Training Session 7 Input Output Redirection and Process Concept. We have been using input output redirection right from beginning, like greater than symbol, double greater than symbol, and vertical bar, also piping symbol. But this session is exclusively for that purpose only, to make you understand the whole concept of input or output redirection, program running, that is process, program in execution is called process, the concept of processes. So you will find connectivity between the old system, old sessions which we have done, and some new concepts may emerge during the session. So just enjoy the session. The agenda of the session is standard input and output, redirecting input and output, redirecting and piping, overwriting or appending, redirecting standard error and both standard output and error, using pipes to connect processes, useful pipe targets, what is the process, how processes are created, process ancestry and process states, viewing the process, sending signals to processes, terminating processes, interactive process management tool, altering process scheduling priority, running a process in the background, suspending a process, listing background and suspended jobs, and resuming suspended jobs, and compound commands. So many topics. I'm sure you have some of the connectivity, and I'm sure you recollect that yes, we done this directly or indirectly. It came earlier in the discussion somewhere. Standard input and output. Linux provides three input-output channels to processes. Standard input, keyboard is the default. Standard output, terminal window is the default. Standard error, terminal window is the default. So error messages could be saved in a file with normal output going to the monitor. You need to remember these three numbers. As of now, no further explanation other than that these are three numbers, 0, 1 and 2, and in this output redirection, input redirection, we call them as file descriptors. 0, 1 and 2 are file descriptors. 0 is for standard input, 1 is for standard output, and 2 is for standard error. These are the three file descriptors which we need to remember. Then we will start working on that. Processes. Standard input, standard output or error can be redirected to alternate locations. Let me demonstrate with a simple example before even the discussion starts, because when I explain, when I demonstrate, you will be able to connect with the topic. So here I'm running my Linux machine, and let's start. So I type something which is not a command, not command. Obviously it will generate error message, and this is error message generated by this command. Or as a normal user, su/sang1, sorry, su-sang1, and I try to access ls/proc file system, proc, which is virtual file system. I may not be able to get the access to all the files of some directory, let's say user bin or some other systems. I just want to see some of the files where I don't have the access. So I want to see user bin or some other files where I don't have the process, I don't have the access, maybe etc, right? So there might be some files where this user may not have the access, and the command we generate error messages, no such command. The output is generated, error message is generated on the terminal, but can I redirect this error message to somewhere else? I can do that by typing 2 greater than symbols, because 2 is the file descriptor for error message. Greater than is redirection. So error dot txt, let me send the error message to txt. Now the same command which sent the error message to the terminal is used again with error output redirection to error.txt. Therefore, if I use cat command with error.txt, I'll get that message here. I could have by default this cat command display the output on the terminal. If you don't want to see the output on the terminal, you can specify the output redirection, or to be precise, to be exactly clear, absolutely clear, you can use one greater than symbol and message. Let's say anything, msg file, and this time this output of cat command which was displayed on the terminal is rather than sent to a file, because one is the output redirection or file descriptor for the normal output or standard output, and the output has gone to this file. So therefore I can use cat command to again to display this message msg file. So now the message is stored into this file. In other words, you can redirect the error message with 2 greater than symbol. You can redirect the normal output with 1 greater than symbol, or even that is not required. Like if you type, by default 1 is understood, so simple greater than symbol is also okay. I repeat, 1 greater than symbol is making it exclusively visible and mandatory. A greater than symbol means it is understood that it is 1 greater than symbol, so 1 need not to be specified. The meaning will be the same. However, if I want to append the next error message at the end of this file, then I have to use double greater than symbol. Like ls command will generate the list of files. I want to send this output to the end of this file, message file, msg file. What will happen? The output of this command will be appended. Double greater than symbol means append, add at the end. msg file means at the end of this file. So let's do and let's see what happens. So contents are sent and added at the back of the end of this file. We can verify that msg file, and you see first message was command not found error, and after that all the output of the command ls is sent to this file. So therefore we can use cat command, I mean greater than symbol, double greater than symbol, 1 greater than symbol, 0 greater than symbol, input redirection. Okay, let's start with cat command. By default, cat takes the input from where? From the terminal. Simple type input, and you type anything and it will echo back same thing to you. Control D is to exit. By default, sort command will take the input from where? From the terminal. You type anything and it will sort them. Press Control D, it will sort the text. Look at this, it is sorted. You may say it is same. No, it is not same. Let me start with the reverse order. I am typing character in non-ascending order, and I type Control D, and now you see it is sorted. So by default, sort command is taking input from the terminal, sending output to the terminal. We can redirect both of them. Now how? Let's do again sort input redirection. Alright, means take the input from, let's say we have a file names, if you remember, names. Oh, what was the file name? It was names only, if I am not wrong. Oh, I'm working as Sang1 user. The file was under root user. Okay. Sort input redirection names. Meaning is simple. Don't take the input from the terminal. Take the input from the file. And this is input redirection. So I can type this sort input redirection names, and it took the name from the file and sorted them. And if you want to send the output also to some other file, you can use output redirection. Let's say sorted names. So this time it has taken the input from name files and sent the output to the sorted name files. So we have used input redirection as well as output redirection in this command. Sort is the command. This is the file. We are taking input from this file. We are sending to this file. If I want to append the content, if I want to do the sorting again and want to append, I can use double greater than symbol. So this will add the file, sort again, and will send the list again to the same file, and we can verify that. Sorted names. Look at that. It has appeared twice. The list has appeared twice here. So that is input and output redirection. Now you will understand the theoretical concept once the demonstration is given. In standard input, output and errors can be redirected to alternate locations. Shell redirection operations allow standard input output channels to be redirected to or from a file, which I demonstrated. Pipes are allowed standard input output channels to connect to the input or output of programs. Difference is very clear now. Please understand, there should be no confusion. To or from a file or a program. When you are talking about program, you have to use pipe. When you are talking about redirection operations of the contents of a file to a file, you have to use greater than less than symbols. So pipe is for program, input output redirection is for file, right? So if you want to send the output of a program to another program, then you have to use pipe. If you are sending the output of a program to a file, then you have to use input output redirection. So input output redirection or pipe, it depends on where you want to send the output. You want to send the output to a file, you have to use a redirection symbol. You want to send the output to a program, you have to use pipe symbol. Although it is possible to pipe standard error into a file using some fairly complex syntax, but that is generally not done. So this is what the meaning is. Input output redirection. I just explained the symbols and demonstrated. Output redirection, append output redirection, input redirection, to greater than error redirection, and append the error to the file. And this is example: command followed by output redirection followed by file. So output of this command will be sent to this file. Double greater than symbol meaning appended. Output of this command will be appended to this file. I have demonstrated this also. I have demonstrated all of them except this, and now this should be self-explanatory to you. Vertical bar is the piping, where you want to send the output of one command as an input to another command. This is the piping symbol. So piping symbol, vertical bar, is used to send the output of one command as input to another command, and which we have been using throughout the sessions. In the previous sessions also we used it. Overwriting or appending. Single greater than symbol will overwrite if the content or the file already exists. Double greater than symbol will append if the file already exists. If it does not, it will create it. So that the meaning is simple. So standard error will be displayed. Still it will be displayed on the screen, because this output redirection does not mean that your errors are also sent to the file. They will still be displayed on the terminal window. So there should be no confusion that single greater than symbol is for only the output, not the errors. For errors you have the symbol 2 followed by greater than symbol. So redirecting the standard error is done with 2 followed by greater than symbol, which I demonstrated. So you can use this also: find /etc -name passwd 2 greater than symbol find errors. So meaning is, whatever the output of this command is, that will be displayed on the terminal. Whatever errors are generated by this command will be sent to this file. So standard output is still displayed on the terminal, and the errors are sent to this file. So basically we can control the errors, we can control the output by using this greater than, single greater than, double greater than, 2 greater than, and all these symbols. Now if you want to redirect both of them, You want to redirect output as well as you want to redirect the error. So to redirect both error and output to a file, you can do it by using this 2 followed by greater than symbol for the errors and single greater than for results. Quite obviously, errors will go to the error file and the output will go to the results file. Now each input output channel can be redirected to different files or to the same file. Look at this. This is a very typical example, very interesting example. What this command is doing, sending the output to this file. But this message here is very interesting. This says errors. Error will go to &1. &1 means add, and 1 was file descriptor for output redirection. So we are saying send the errors to file descriptor 1, which was standard output and which was this file. So in other words, this simple meaning of this text is simple, that send the errors also to the same file, all output. Let's try this command, because this example have been used in past 2-3 slides, and we will use these different options to verify that. Okay, so we are trying to locate a file under root directory and we'll send the error messages to the error file and results to the result file. Let's take a look at. Because what is new in this slide was only thing that we are redirecting both to separate files. So find command we did earlier from root directory -name passwd and 2 greater than symbol. By default, in fact, if I do this command directly, it will display the errors also here and the output also here. Alright, it will display the error messages and output both at the terminal, and you are getting the output right now. This is the output. I'm sure this command will generate some errors also. Let the command complete, and you will see the errors also being displayed on the terminal, because there are some directories where you are not allowed to navigate, and wherever you are not allowed to navigate, you will get permission denied error there, and that means that is the error. So error will also be displayed on the terminal, and that's why I have given searching from root. I'm searching from root directory. So within root, wherever the passwd file is appearing, wherever the file passwd is there, display that file here. So right now we are getting the errors. We are we are getting the output. We are still have not got any errors so far. So that means it's not generating any error. But if I try as user root, as user sang1, I'm sure I will get this, because sang1 definitely will not be allowed to access certain files and directories. So let me try the same command as user sang1. Look at this. What am I getting? I'm getting permission denied errors. So many errors I'm getting. So therefore I can use that command here as user sang1. So same command, send the error to this file. Let's say errors, errors. Errors will be sent to this file. Fine, absolutely. But where the output will be displayed? Output will be on the terminal, and which is displayed here. Look at this. If I want to send the output to some other file, so I can use symbol greater than symbol. So let's say output, right? So which means the errors have gone to errors file and output has gone to the out file. So we can use cat command to see the errors, and these are the errors, and we can use the output. We can see the output also. Now the situation is, let's remove both the files, rm errors, because I want to demonstrate something else also. rm output, and now let's try the same command again. I want to send both of them to one file. So I can do that by using, instead of this, what I do is I use greater than symbol, that is output, and in fact let's send the output to, let's change it here, send the output to output, and errors to, for to sending that, to redirecting the errors, I use two greater than symbol, and I want to append them at 1, which means that send the errors also, this means the errors, to this output, means the file descriptor 1, which is here, which is this one. This is file descriptor 1 redirecting the output. So this means the error messages and output, everything will go to single file output. Let's take a look. If I use cat command on the file output now, you will see the errors also and output also. These are the errors, and output, definitely output is on the top. Errors and output both are available on this file. Look at this, this is the file, so this is visible here. So this is output, and we have, wherever the output is, we'll get the error output also, and wherever we have the errors, we'll get the errors also, but everything is in this file now. Everything is in this output file. So this way you can redirect input and output both to single file. There are two ways to do it. So we have just seen this part. This can also be done with this simple ampersand greater than symbol. This so this option, or this option, all are one and the same thing. You can use any of them. You can use either this or this or this. All are same thing. So that is for sending errors and output to a single file. Redirecting input, we have done that with sort command, and I'm sure you recollect that I demonstrated this. This is the tr command, which is doing the same thing. Tr, translate uppercase A to Z to small case A to Z, and we are taking the content of the etc bash profile or .bash underscore profile. Let's try to do this also, because we have done one example, but we can do more examples. As many examples as we can do, we should try. Now let's try this. Now exit from this file. Now use tr command, tr within single quote A to Z, translate to small a to Z from the file input redirection .bash underscore profile. This is the file which we had. Now you see everything is converted to lowercase, but let's do a vice versa, and so that we understand, yes, it is working or not working. Small a to Z, convert to uppercase A to uppercase Z. Now you see everything is converted to uppercase. Only thing is that our emphasis was on that, not the translate command, but taking the input. Input is taken from the bash profile. So we can do this for input redirection. That's how input redirection works, and I demonstrated the same thing with sort command also. Piping to connect processes, we already done that, like we did that in the previous session. Cut first column, separated is colon, from this file, sort them in reverse order, send them to the less file. So we are using two vertical bars here, that means two piping symbols. It's nothing complex. This is first command. Output is sent to this command with -r switch. Whatever the output is generated by this command is sent to this command. So this way you can connect multiple programs by sending output of one to another, and you can use as many pipes as you want. Look at, there are some more targets, more examples of on the piping symbol. ls-l less command, we have been using it. ls-l mail the content of the file to the with the subject file to this user. ls-n lpr cat file name, delete files to delete, and then send them to xarg rm-rf command. So this way, these are some of the examples where we talk about the output redirection of program to another program, or output redirection of a program to a file. T. T, as the symbol suggests, the T symbol is something like this. We have T like this, and a T symbol is made of basically this is a kind of T symbol, right? So what we have in the T symbol is we are sending the input and it is going to two different locations. One is the mandatory program and one is the file. So we are sending to the file and we are sending to the program that can be done. So basically we are sending the output to another program or file, and we are sending to the terminal also. So this is example of T, sending the output of one program to two different locations. Take a look at set is a command. T meaning is send the file to send the output to this file, also display them on the terminal, or send them to this file less, or this command less. Look at another example. Command T stage 1 output will be sent to this file, plus output will also be sent to sort command. Now T again, after that output will be sent to this file, plus the output will be sent to this command also. -C. Again T means output will be sent to this file, plus output will be sent to this command also, and we can continue doing so. So T command will send the output to a file plus a command, and that's the example of T. So T is used where you want the output to be sent to another program and output needs to be captured in a file also. Now the process. What is the process? Process is any program in execution. When you are executing a program, you are running a process. Any process when being executed, we have separate characteristics, separate we have some characteristics or attributes of a process, like exec thread, process ID, priority of the process, memory context, environment, file descriptors, and security credentials. All these things are characteristics of any process. I repeat, process is program in execution. So we'll look at some of the commands to understand the process, to display the process, hierarchy, to find out these characteristics, and to change the process characteristics also wherever required. We'll do all these things in this session, and we'll take a look at how they work. We have discussed this concept of fork and exec earlier. Basically, fork means you are calling or initiating another shell. You are starting another shell from the current shell. So it is a part of extension. So once a process forks a child, means from existing process, once the new process is generated, and this is a small process, so this is a child and this is the parent. Once the process fork a child, this is called fork, pointing to the same page of memory. They have the same memory area. This also is using this process is using this memory, and this is also using the same memory. So they have same home. They are residing in the same home. Look at it from our own family angle. If you want to understand from that point of view, when the child is born, we still have the parent and children living at the same home, same place. But problem occur when the child get mature, he become adult, and he wants to take his own decisions, and that's where we say we kick them out and we say, okay, go to hell, or live your own life. You take another property, live somewhere else, but we cannot allow you to live here. That's where the child becomes independent and child is allocated a separate memory area, right? So this is applicable when this child becomes adult or want to write something separately on its own memory area. We call it as write fault, or making the area only for a child, separate identity for the child. So this is a very interesting concept compared with our own principles, our own family principles. So look at this from the technical point of view. Once process fork a child, pointing to the same page of memory and marking the area as read only, because this memory initially is used by both the processes, so it is a common to both of them. Then the child executes the new command, causing a copy on write fault, thus copying to a new area of memory. So that is making its own separate memory area for this process, and this no longer be a part of this memory area, and it takes its own path and become an independent process. A process can exec without forking also, which we learned right in the session number 2 or 3, I think, where I explained you can directly use the exec command to start a process, or replacing the parent itself. The child maintains the process ID of the parent in that case. This line talks about the concept where I explained that difference between exec and fork. And I said exec, when you execute any command with exec, you retain the process ID of the parent and you replace the parent. I explained this with example. But normal process is this: first we have the fork command whenever a process is created, and then the moment this process start writing something, we have a copy on write fault, and whenever the copy on write fault happens, we create a new memory area for the process, and this process is generated with a new process ID. So we have two different processes, and this is the birth of a new process, or our new process is born here. This was theoretical concept. And process ancestry. Systemd is the first process started at boot time. We can use the pstree command to see the process hierarchy. Let's take a look. Which process was first, what all processes were born, and which process is child of which process. We can look at everything with pstree command. And this quite big output, so we can use more command to filter this. So this is the first process. This process started modem manager, all right, and these are all child processes. This modem manager, network manager, all these processes are children of systemd. System is the parent. Now if you want to look at another grandchildren of systemd, we can take a look at this example. Audit D, AUDISPD, and we see here another child, so audit D process. And if we go down like this, we'll see the hierarchy, process hierarchy here, like this. So GDM is the children, this GDM is a child of systemd, and under GDM we have this process. So this hierarchy continue, the parent child here relationship continues, and look at another hierarchy here. This is the children of systemd, and then we have GNOME PTY help page. So this is grandchildren. So we have this concept of hierarchy of parents, one process starting another process, and we have parent child relationship among the processes. Except systemd, every process has a parent. Process can be both a parent and child at the same time. pstree command shows the process ancestry for all processes running on the system, which we just saw. Every process has different state, can be in any of these states. Like a process may be runnable or in the run queue. Meaning is the process is in the run queue, it is waiting for its turn to run or it is executing right now. Hyphen uppercase S, it is not hyphen, actually it is state. S means it is sleeping. Process is not executing, it is not ready to run, it is waiting for some event to occur, somebody to come and tell it to run, or a signal to arrive to wake it up, because it is sleeping. Somebody should disturb it, somebody should make it awake. Come on, get up, it's time. That is sleeping state. Stopped, process is not executing because it has been stopped manually by the user or by another program. Uninterruptible sleep, so you have put a tag at the door that don't disturb me, I'm sleeping. So process is sleeping and cannot be woken up until an event occurs. It can be woken by a signal, typically the result of an input output operation. And defunct or zombie process, just before a process dies, it sends a signal to its parent and waits for an acknowledgement before terminating. It's like before a process dies, it takes the permission from the parent to get relieved. So once the parent gives the permission, once the parent acknowledges, then it will go off. Else the process ID will be there, and we call it as defunct or zombie process. Even if the parent process does not immediately acknowledge the signal, all resources will be released except the process ID number. So zombie processes are cleaned from the system during the next system reboot, and they do not adversely affect your system performance. So that is zombie process. Viewing a process is the command ps command. We'll take a look at various options of the ps command, and let's try to understand the processes. That's a very interesting command, very powerful tool. In fact, I'll not call it as a command because it gives so many things about the process. So ps command, simple ps, it will show only the terminal processes. ps-a, display all processes. au, all user processes. X, show me the exhaustive list of processes. Show me the configuration files also. So -L, show me the long list of L is not applicable, sorry. So these are different, and show me the security context also. Look at kind of information we get with the px command. Px have so many options depending on need, and let's look at the headings and the title, what information is displayed with this ps command. Here we start with this. This is the command we give. User, who run this command? What is the process ID? What percentage of CPU time is being consumed by this process? What is the memory being used by this? VSZ, virtual component of the memory. RSS, TTY, state of the process, sleeping. S means sleeping, R means runnable. We just saw these process states. Start time, command, the command which is used to start this process. So this is the concept of process. We'll take a look at the options which are used during the output and different options with the ps command. So useful action, we used A, processes by all users. X, process from all terminals. U means show process owner, which we saw using U option. W means include the command line arguments. F means show process ancestry. -L means long listing. I noticed that this option was not working now. Earlier it was there, it used to work earlier definitely. So might be it is exceptional that it cannot be used by some other option. So we may try with only -L. So this way you can use the process and grab the required process, whatever we want to monitor. So grab, we will be doing a regular expression. Grab means searching for a given string in the output. Of course we are using output redirection, piping symbol here, because the output of this command is sent as input to another command. Or we can simply use pgrep lpd. Kill, this is how you send a signal to a process. You can send signals to processes like kill followed by -signal followed by process ID. So first thing is you need to know the process ID. Once you know the process ID, you can send a signal to process ID or the job ID. Send the specific signal to a process. Default signal is TERM. We have so many signals. If you want to display all the signals, you can use -L, kill -L. Alright, let's take a look at the kill command and terminate a process. So what I'm starting is I'm starting a process, let's say vi test file. Alright, now the process is started, vi editor is running. I open another terminal and I want to see the process ID of this. Okay, what I use is ps aux and grep vi because I want to see the vi editor. So, or the test file, I can simply specify the test file also to be precise, because I just want to look at the content of that file, because I started one file and I want to see the process ID of that. So this was the command and this is the process ID. So what signal can I send to this process with process ID 6586? So I can use kill -L command to see all the signals, and these are the signals. Signal 1 for SIGH hub. Important signal is 9, which we use frequently. That is, we call it as signal kill, and that's the best signal. We always try to terminate. Not all signals will work. Remember, please don't misunderstand that all signals are working and we need to learn all of them. No, definitely not. Because signals are characteristics of the program, which means the VI program will decide what all signals I can take, because the programs are designed, programs are created to respond to selected signals only. It's not that you can send signal number 61 to this VI command, not possible. So not every program will take any kind of signal, but yes, 9 is quite common signal, and I'm going to send the signal number 9 to this process. So process ID is 6586. So kill -9 and the process ID is 6586. This will terminate it. Kill -9 6586 and the process is terminated. How do we check? You open another terminal, you will get your prompt back, and look at this, and you got the message process is killed, and you got your terminal back, your prompt back. That is what the process. You may ask me, okay, when do we need to kill a process? I think answer should be short and sweet. Whenever you are stuck and whenever your process is not responding. Open another terminal window, check the process ID and simply shoot the process, kill it. As simple as that. So it is not a quite common thing. Whenever we are stuck, whenever we are not able to get the kind of response we are expecting from the signal, from the process, we simply kill them. Alright, so kill can send many signals, but this is what I warned you guys. Process only respond to the signal they have been programmed to recognize. So it is the program, it is the process which will decide that I will respond to this signal or not. Signals may be sent to process interactively using top command or GNOME system monitor. Let's take a look at these two commands also, top command and GNOME system monitor. I'm loving this demonstration because I'm getting a kind of feedback from the participant that you focus on theory, you don't demonstrate much. So I have changed my methodology a bit now. I more focus on demonstration. Top command. Top command will show you the live processes, the processes which are running right now on the process CPU, and you are actually what you are seeing right now in your CPU. This is what is going on in your CPU. You see everything here. You see the process ID, you see the user, you see the priority of the process, you see the niceness value. I will explain that niceness value, don't panic. This is virtual memory, this is RES, SHR. We'll understand these columns. This is the state of the process, memory utilization, CPU utilization, and time, and the command. So we can send the signal from this top command, and you come out from here, and you can also use system gnome -system monitor. This is the GUI version of the process, or GUI version of the top command, and here all the processes are shown here also, and you can send a signal to this: stop, kill, continue. These are all signals only. Stop. All right, you can kill the process. So this way you can send the signal directly also, and from the command line also, and from the GNOME system monitor also. This is also nothing but the top command. So this will show you all the processes, this will show you the resources, and this will show you the file system. So you can monitor everything with GNOME system monitor. Right now you see the CPU utilization, you see the memory utilization, and this is the GNOME system monitor command. So you can send the signal from the to the top command, or that is live processes. You are sending the signal to the running process, and GNOME system monitor also. Terminating a process, we can use generally we should avoid doing it. Most desirable way to end the process is let it die, let it end normally. Once it finishes its job, it will definitely end. Commands finish, applications are executed. This is a normal process. But if you feel that no, it is taking too much of time and it is not responding the way it should, you can interrupt with Control C, or you can send a terminal signal, TERM, terminate. If all fails, then you can send a kill signal. Using kill signal on a routine basis may cause zombie processes and lost data. So you should avoid using kill frequently unless you feel that it is absolutely necessary to kill the process. Interactive process management tool. I just showed you the top command, and I showed you GNOME system monitor. You can use manual pages for understanding the output of the top command and the GNOME system monitor, which you saw just now, man top or help pages of system monitor. Running a process in the foreground. When a command is entered, the shell will not process further input until the process is complete and the shell prompt is redisplayed. We call it as job control. Meaning, I want to start a command, and the command is going to take time. You know that the prompt will not be displayed until the command is complete. Certain situations demand that we don't want to wait for the command to complete, and we want to issue another command, which means I want to manage my job queue, and I want to add commands or processes or jobs to the queue and manage the queue myself. In other words, I'm talking about job control. The type head buffer allows you to type other commands, but they will not be processed until the pending processes are complete or returns. But still you can create processes and you can put them into the queue. Altering process scheduling priority. The nice command will start the process with a given priority. Priority basically refer to how important this process is for the execution. By default, every process has a default niceness value of 0. However, we can change that. You can adjust that. But adjustment from a given range. And the range is from -20, which is the highest priority, to 19, which is lowest priority. minus 20, minus 19, minus 18, minus 17, minus 1, 0, 1, 2, 3, 4, 5 up to 19. So 19 is the least priority, minus 20 is the highest priority. You can start any program with nice followed by the priority which you want to specify in the program. For example, nice hyphen n and the priority and my program. Let's take a look at how it is working. So we will do vi editor, vi test file. We are doing the same process again. And now what we will do is we will open another terminal window and we will see the top command to see the niceness of this project, the vi editor. Alright, we'll see the niceness value of the process. Let's sort it. One second. Where's the vi editor? Better is I use the top GNOME system monitor. That will be better so that I can see the priority or niceness value of this. GNOME system monitor. Here I will see my process which I started with the niceness value, because the processes are listed in alphabetical order, and I'll verify my vi editor somewhere and I'll see the niceness value. Yeah, here it is. So this is my vi editor, and you see the process ID of this is 7303, and I'm not able to see the niceness value, but no problem. What I will do is I know the process ID now. I want to check the process ID of this. I want to see the niceness value of this, right? So I simply use 7303 to check the niceness value, and I can verify that, right? But I must be seeing some additional column. I can specify here all processes, dependencies, active processes. Let's see all processes. All processes. Where's the niceness value? Dependencies. I want to see that niceness value, but I'm not able to see that in this output actually. Priority. It is given in the textual format. Top command gives the process proper process priority by means of niceness value. Okay, no problem. What I will do is let me see if we have an additional column here. Preferences. I'm sure, yes, here we can add that column. Nice, here it is. We can customize that and we can get the niceness value. This is what important point is. So we can add columns and we can get the niceness value also. Now we got the niceness value. So here it is the nice value. Now let's take a look at that niceness value of the vi editor, because I want to see that and I want to change it. So this is my vi editor, and the nice value is 0 by default. That's what I wanted to see. Now what I'll do is I'll start my another process. Alright, I'll close my terminal. I'll come up to my vi editor, and now I'll start my nice value. I'll start with a different priority, nice hyphen n 15 and the vi editor test file. Alright, now if I see the priority of this process, what it shows me, let's take a look at this. Now what is the priority of this value? Look at that. Now the priority is 15, means very low priority. Process size is different, niceness value changed, right? We call it as changing the priority and starting a process with low priority. Let's close the terminal and let's start the process with another priority. Okay, now can I start with a high priority? Minus, because high priority means minus sign. minus 15. Can I start it? Yes. Let's take a look at what is the priority now of the VI editor. Look at, now it is minus 19. So now the process is started with a high priority. It will be pulled over other processes and it will get the maximum priority from the CPU. So therefore, this is how you start process with the different priority values. Can we change the priority of running process? Answer is yes. So let's look at that also. We have just learned how to start a process with a given priority. Non-privileged user may not set niceness value less than 0, but as root user I can do that, and I did that. In fact, I started my priority with minus 15 also, with priority minus 15 and with low priority of 15 also. And this is a function reserved for super user because I was working as a super user, so I had whole right to decide the priority of my program. Renice command is changing the priority of running processes. So renice the number, process number, and the process ID and the user, where the number is the priority value. For example, renice 15 hyphen p and the process ID. You know process ID, how to identify the process ID. We just saw the process ID of the VI editor also. So when the process was running, we could change the priority with renice. Let's take a look at and we'll try seeing the same thing and how it works with the renice command, or changing the priority of the running process. We'll do the same process again. We'll do this exactly same step. Okay. Now I'm starting the process with priority 10, normal priority, low priority. I'm starting this process with low priority, and this process is started with a low priority. Let's see what is the priority of this process. So we have the priority is 10 right now, and we know the process ID is 7711. So let's change the priority of this process with the renice command. So let's open another terminal and renice, then priority is minus 10 or minus 8 hyphen p. We don't have to specify minus sign or hyphen sign. Renice the value of niceness hyphen p, and the process ID was 7711. If I'm not wrong, let me just cross check. Yeah, 7711. By default it was 10, low priority. I'm changing to high priority of minus 8. Of course minus 8 was the priority, so I want to specify negative sign. I'm sorry. The high priority is minus 8. So old priority 10, new priority minus 8. Let's take a look at. Yes, it is done. So process was running and we have changed the priority from low priority of 10 to high priority of minus 8. And that's how we can set the priority of running processes as well. So this way we can change the priority of running processes. So low priority with a plus sign, with or without any sign. Low priority. High priority means with minus sign, and the range you know is from minus 20 to 19. Running processes in the background. Running a command in the background allows another process to run concurrently on the same terminal. How can you do that? Launch a program as a background process by appending ampersand sign at the end of the command, like Firefox ampersand sign. The program will run in the background, and it can be managed like any other process by using the niceness value or kilt terminal, or you can work with it. Can you suspend a running process? Can you temporarily put a process on hold from being executed? Yes. How? By using Control Z command. So you can suspend the execution of the program by pressing Control Z. That does not mean that process will be killed, process will go. No, we cannot. That does not mean that. Let's understand what am I trying to say with example. Okay, now we know that VI process is running and we know it is open here. Look at this. The process is running right now, and you see the status here also. Right now it is running, right? priority very high, niceness, started, state. I'm not able to see the state, so let's add the column. We know how to add the column now. We have just seen the preferences and we see the status of the process, right? Now you see the status. Where is the status? Yeah, here. Right now it is sleeping. Now let's suspend it by pressing Ctrl Z. So if I press Ctrl Z here, the process is stopped and go into the background. Right? Now let's take a look at. Now it is stopped. Earlier it was sleeping. Alright. So this way you can change the status. You can send the process in the background. Surprisingly, now the process is running in the background. Process is running. Right? Suspended. If I want to give the command jobs, I will see my stopped process here. If I want to bring this process again to foreground means I again want to edit the file. I want to see my VI editor. I want to again want to work in the file. So what do I do? I will use FG, that is foreground. FG and the job ID. We call it a job ID. This one is the job ID. So FG %1. So %1 will get this job in the foreground, and you see I'm back in my editor. So Control Z, sending to the background or suspending it, and FG, bring it to the foreground. So running the process in the foreground or background, that's the concept. Resume in the background is BG, resume in the foreground is FG. When the job resumes, it will continue executing from the point at which it was suspended. It will have no start over from the beginning. It will start from where it was stopped. Jobs, I just displayed the command. I showed the command. It will display the process running in the foreground or that were suspended, running in the background, sorry. And I showed that, and I use the % to see my process, to pull the process from background to foreground with %. And this is what I did. FG % job number. Same way you can do BG % job number. Foreground for FG and BG means background. Compound command. We done that right in the beginning, that how can you issue multiple commands in one go. You simply put them into parentheses. So parentheses, first command, semicolon, another command, and then you want to run them in the background, %. %sign is not mandatory here because here this means that we want to run the program in the background and we don't want that. So % is not important here. Look at this example. We did that command earlier also. Date is one command, who is another command. Both these commands put together, the output is sent to log file. So this is command group. When we put command group, or we want to create a group of commands together as single, we do it by using parenthesis symbol. We call it as compound command, and examples we did in the one of the previous session. Alright, and that's all for this session. I hope you enjoyed it. Thank you so much for watching. Bye bye.